Welcome to all our participants. I see 19 at present, which is nice. Thank you very much for coming. My name is Christian Weber from Technische Universität Ilmenau in Germany, and I have the pleasure to chair this session on requirements engineering. We can look forward to 5, I think, inspiring presentations covering different topics of requirements engineering, some new approaches we will see, and I'm looking forward to the discussion. We see short versions of all these contributions in a pre-recorded form. That's the first topic of our session. And afterwards, we should have about half an hour for discussions. If possible, please place your discussion contributions in the chat. You find the button on the top right of your screen, and then in the bottom you can fill in questions. If you ask questions, please state clearly to which of the contributions or presenters this question is aimed. I think we can start with having a look at these presentations. They had to be short in order to get the conference properly running, but you can all go to the final papers. You see the DOI specifications in the program. So I think these are 5 presentations in a row. Now coming up and starting with Mr. Robert Mies from Technische Universität Berlin in Germany, and he will present on the development of open source hardware and requirements necessary for this type of engineering activity. Yeah.
The 5 presentations will be played now in a row.
Hello, this is the first presentation of the requirements engineering session. Our work is called Development of Open Source Hardware in Online Communities, Investigating Requirements for Groupware. My name is Robert Mies. The co-authors are Jérémy Bonvoisin and Renan. We are from the Technische Universität Berlin and the University of Bath. We are supported as part of the research project OpenNext by the H2020 program, grant ID 869984. Let me give you some background. Free and open source software gave rise to a €1 billion economy, as you know. Open source hardware is the extension of open source practices from software to electronic hardware to mechatronical and mechatronic products. Examples are below: the Linux project in the 1990s, early 1990s, the Arduino project in the mid-2000s. Another example is the Tabi Evo electric vehicle platform by Open Motors, which shows a complex open hardware product. According to the DIN spec 3105-1, open source hardware is hardware for which a free right of any use belongs to the general public and whose documentation is completely available and freely accessible on the internet. Also, groupware describes computer-based systems that support groups of people engaged in a common task or goal and that provide an interface to a shared environment. Groupware for the development of complex open source hardware supports interaction of geographically dispersed individuals, often around the world. Now, we looked at dedicated groupware solutions for open source hardware. These have been combining distributed workflows from FOSS development and conventional industrial product development support. No dominant design has emerged so far, and take-up is modest. Instead, we have even observed repurposing of available groupwares originally developed for FOSS development. This is a problem, as the depiction below shows, based on Fjellstedt et al. 2012, because it is the platform that enables the community and the development, and from where the business emanates. So what are the objectives of our work? This work aims to contribute to the emergence of supporting groupware for open source hardware by discovering requirements of practitioners for groupware solutions and by providing a benchmark of groupware solutions used by open source hardware practitioners. We used a three-step approach to elicit, refine, and verify requirements for groupware that supports open source hardware development. Step 1 was to conduct 23 semi-structured interviews. We made notes and transcripts, and from there derived an initial list of requirements. Step 2 was desktop research on groupware usage. We understood the requirements better thereby, and refined and extended the list of requirements accordingly. The last step was to check the fulfillment of requirements by groupware solutions, and this allowed us to verify the list of requirements. Also, we identified and categorized the requirements within the following 4 collaboration dimensions based on the works of Linnemann et al. 2016. These are communication, coordination, knowledge integration, and information logistics. From there, we conducted a benchmark of the 5 most commonly used groupware solutions. These were GitHub, MediaWiki, GrabCAD, Revolver, and Wikifactory. Each time a requirement was met, 1 point was awarded. The varying profiles of the groupware solutions illustrate their different strengths and weaknesses to facilitate open source hardware development. The gray fields show their strengths in comparison to the others. Gaps were also identified in terms of offered communication channels, dedicated functions for requirements management, or data federation. This work takes a snapshot in a very fast-moving environment. The elicited list of requirements and the benchmark are hoped to provide orientation for practitioners and challenge groupware providers to address their needs. There's plenty of rooms for open source-based peer-to-peer solutions as well. Further research has also been conducted in our research project OpenNext, where needs were collected and assessed and user stories developed. Please find our references as follows. Thank you for your attention.
Thank you for providing this presentation.
Hello, my name is Hassan, and I'm glad to present you today our research work about design thinking to enhance requirements analysis in system engineering. Let me start first by introducing my research laboratory, ARPI, in Nancy, in the northeast of France. We are working on different research topics like innovation management and assessment, use assessment, decision support system, and integrated design process and manufacturing. In our paper presented in Design 2020 conference today, we deal with system engineering and design thinking concepts. System engineering is a transdisciplinary and integrative approach to enable the successful realization, use, and retirement of engineered system, while design thinking is an innovation approach that enables the development of an innovative product or service that is desirable, viable, and feasible. Our objective is to analyze system engineering and design thinking approach and to study the interoperability and complementarity between them, particularly in the elicitation and needs analysis phases. So we are starting by analyzing the models and tools used in each approach. For example, in system engineering, we see that a V-cycle system development process model is proposed, starting by concept definition process and activities like business and mission analysis and define needs and stakeholders. For design thinking process, Stanford University proposed a 5 phases model, starting by emphasize with the user, then define, ideate, prototype, and finally test phase. Studying these 2 models, we can see that S system engineering model already well structured in terms of formalizing and documenting development activities. while design thinking can bring an innovative vision and better understanding and involvement of the user. That's why in our proposal, we can see that activities from different phases of design thinking approach are integrated and to feed some information necessary to the system engineering activities. This show in concept definition process and also in system definition processes. To illustrate our proposal, we have conducted a case study from IBM Corporation Security System. In this case study, we have used journey mapping, which is a tool of design thinking approach that allows us to observe new trends and needs expressed by the employees. The figure here shows a use case diagram with different actors, camera, access point, etc., and different use case of our security system. By using journey mapping, we have identified new trends and needs of the employees highlighted here, like a need of cleaning system for the fingerprint scanner and a need of automatic card reader and also iris scanner. So we support that the system engineering model is improved by introducing and using design thinking tools. As a conclusion, so design thinking can contribute and improve system engineering approach by better understanding and integration of the customer. And we can also detect new needs of the user and study also the impact on the acceptance level of the final solution by the customer. As a future work, we can study also the contribution of system engineering in design thinking. Thank you very much, and I am ready to answer your questions.
Thank you. That was nice.
Dear listeners, my name is Dennis Horber. I am working as a researcher at engineering design at Friedrich Alexander University, and today I present our developed conceptual model for a semi-automated derivation of evaluation criterion in requirements modeling. First, I would like to express the motivation and the goal of our contribution. Let's imagine a company with several different teams from different domains working on a complex product together. When specifying requirements at the beginning of development, a major difficulty is an unified understanding of every involved person about these requirements. These requirements are then used to develop different alternatives, and in order to examine which alternative is developed further, multi-criteria decision analysis is used. When taking a closer look at decision analysis, there is a need for a criteria model which contains all criteria. The overall goal of the decision analysis is to evaluate which alternative fulfills the given requirements as best as possible. Therefore, a consistent link between the requirements and the criteria model is essential, especially in complex development projects where large numbers of requirements have to be considered. An automated approach is beneficial to reduce manual effort. Because literature gives no suitable solution, our approach addresses the following two research questions. How can the linkage be achieved, and what manual modeling effort remains with the user? Therefore, we developed a concept to semi-automated derivation of requirements into evaluation criteria. At first, we have a requirement statement as an input, which is then pre-processed by a natural language processing pipeline. Here we use the requirement the maximum weight of the system shall be 10 kilograms as an example. For the purpose of pre-processing, we use the open source library SPECIFICATION, and as a result, we received a pre-processed requirement statement. Depending on the language model, the entities of the requirements are segmented and labeled. This information is then used for a classification of the requirement statement based on a language model which analyzes the semantic information in the statement. We classify the requirements according to their aspect, condition, and necessity. And in the given example, the requirement is quantitative, a hurdle, and a demand. Then the individual classification of the single requirement runs through a rule-based model, which enables the derivation into one of 4 types of evaluation criteria. The given requirement is, for example, derived as a selection criterion. A fulfillment of this type of criterion is necessary, but the degree of fulfillment is not of interest. Now I would like to show a concept how our approach can be implemented in a software system and used within product development. For this purpose, we implemented a conceptual GUI in which developers can type in requirement statements. While typing, the sentence is continuously processed in the backend, which contains our presented approach. The requirement gets classified and the type of criterion is derived, which gets displayed to the user. The derived criterion is then saved into a database, which serves as a continuous source for the following steps of development, especially when members work for the practical of our conceptual demonstrator, real-time capability is necessary. This is achievable through one-sentence processing because only low data has to be processed. Now I want to briefly sum up and discuss our findings. First, regarding the applicability of our concept, which we showed with our software demonstrator and checked with an exemplary requirement dataset. The classification performance is dependent on the quality of the language model. In order to improve that, further development of the classification algorithm is necessary. Regarding the effects on communication and decision-making, a requirement's purpose in decision-making is displayed to the user already in definition phase. This enhances a unified understanding of requirement specifications because by that it is documented how the requirements must be understood. With the semi-automated derivation, we made the consistent linking between the requirements and criteria model possible, and by that we achieve multi-criteria decision-making based on all the requirements. Thank you very much for your attention, and if you have questions now, I am more than happy to answer them.
Hi, my name is Mehmet Ozdemir. I will present our paper, an experiment-driven mass personalization model, application to saxophone mouthpiece production. Mass customization is in the consumer products market for about 20 years, but it is fair to say that it has not been much of a success. Some of the main reasons are high cost, complexity, and failure in attracting customers. A solution to these challenges may be in mass personalization, where uniquely bespoke products are offered rather than a set of choices as in mass customization. A higher degree of personalization may answer the needs of the users and engage them with the products more. Besides, employing additive manufacturing and design automation may help to reduce the cost and labor in the process and bring the products into the willingness to pay range of users. To make this possible, we took an approach to develop product templates that are finalized by users' input. The objective is to explain this product development process for mass personalization over a saxophone mouthpiece example. The proposed model is based on a seed design, which has a certain design space, and the design is finalized automatically with each user's interactive input. The process starts with understanding differentiating user requirements and then identifying variables that affect these. Following these, the dependencies and constraints are identified. The constraints, such as manufacturing or cost, set the initial boundary of the design space. The dependencies of the requirements and variables result in a dynamic design space where each user decision updates the range of further decisions. To satisfy the user requirements, variables are iterated with the main objective of providing the largest design space on each occasion. To explain this further on an example, here we have the process for a saxophone mouthpiece. The first part of the process is based on the literature review. Initially, what features users would like to personalize in a mouthpiece is identified. Design parameters of the mouthpiece are already defined, and the parameters affecting the chosen requirements are selected. The range of each parameter is defined based on the mouthpieces in the market and playability. With this information, an initial design space is formed, and user requirements are mapped onto design variables to show the dependencies. However, the information about these dependencies is not quantified and sometimes conflicting. So, to clarify and quantify these dependencies, the second part is an experimental process. This starts with reverse engineering of a commercial mouthpiece, which is used as a base for the seed design. Then 27 designs created, having each parameter at 3 levels to observe the effects of design alterations. These mouthpieces then 3D printed and played on an artificial blowing machine. Statistical analysis of the measurements provided how parameters affect the properties of the mouthpiece. With this information, the dependency table is quantified and the iteration algorithm is built. Finally, there is a user interface to get the user input for the final design. Here an example of the user input is shown. Since all the variables are free at the beginning, it is possible to choose any value on the scale. The user chooses 7 for resistance, and to satisfy this requirement, initially TO is set to 0. Since the limit of TO is reached and the requirement is not met yet, the second variable BH is set to 7 and the desired resistance is achieved. Once a selection made, as seen in step 2, the following requirements are restricted due to their dependency on SO or BH. In the second step, the user chooses 3 for tone color, and this is satisfied by setting TS to 10 and LH to 4. In the third step, there is only one option left for resistance since all the variables affecting it has already been set. For the last option, the user chooses 1 for volume, and this is met by setting CS to 10. At this point, all the design variables of the personalized mouthpiece are set, and the automatically generated 3D model is ready to be manufactured. This study presented an example of a method to design mass-personalized products focusing on seed design development. How to treat a mass-personalized product development case with user involvement is covered. One limitation of the study is that personalization is only on the functional aspects of the product. Another to mention is that the user aspects are not covered, such as users' perception of the mouthpiece characteristics or their interaction with the tool. As future work, a user study will be done for validation, and the proposed process will be tested on different products. Thank you for listening.
I'd like to welcome you to my short presentation about the paper I wrote with my colleagues from the Institute of Product Development at the Leibniz University of Hanover with the title Discrete Event Simulation for Specification Design of Products in Product Service Systems. I will start with a motivation or more with our case study in this paper. We do have a product service system. This is a simplified business-to-business relationship in the gastronomy or in the hotel sector. And what we have is a result-oriented product service system, which offers the customer a result, regardless how it is achieved. So we are providing coffee cups for hotel guests. And the provider delivers the coffee machines according to an increase or decrease in demand, and supplies also the consumables, so our coffee beans. And for this use case, we built up a discrete event simulation to define our product specifications. So how we structure our modeling approach. We do have 4 main areas modeled for the simulation model. At first, the scenario model defines the restriction and constraints which we have. And then the product service system is modeled from the areas product, service, and decision making. All these deliver us an input of parameter sets. With these, we can compare in the model different parameters, set input parameters, and then we can find an optimum which is derived from the respective scenario and will let us find the product specification for these scenario. For the scenario modeling, we do have a hotel capacity of 300 beds and an average occupancy rate of 70% and a yearly consumption from 190,000 cups of coffee. That's around 2.5 cups per person and per day. The coffee consumption is distributed over the day, which you can see on the left side, and also over the year on the right hand side. The modeling of our product service system we do with the service, which contains the delivery and the return of the machines, as well as the supply of the consumables. With our product, we have the storage capacity variance from 50 to 200 cups and an output time per cup. So how many seconds do I need to fill one cup? This results in 9 different models with estimated costs according to our technical specifications. Our decisions are, on one hand, the delivery of an additional machine with a workload of more than 65% for 5 minutes occur, or the return of a machine in relation to a threshold value if there is an utilization below 13% over 24 hours. And we do have simplified the refill of at a minimum of 10 cups left in one machine. If we have a look on our results, we do have our scenario constant for all simulations, and we do have a maximum waiting time for 2 minutes per person to get a coffee cup. And we do have our overall best model in model 4, and this fits best to the scenario due to the low refill and delivery costs, even though it's whether the cheapest or most expensive machine we have in our simulation. So let me now conclude and have a short outlook. Our objective was the optimal use for the product and decrease the total costs. Our findings are an ideal product parameters. We do have a challenging environment modeling, and smart products are essential in product service systems for better results. And in our future work, we do have the variation of the simulation parameters, which are very essential, and the automation and further modeling of the decision-making parameters. So, thank you for your attention.
It was fantastic. You kept time very nicely. So we have exactly half an hour for discussion. I've seen a small question about the use of the word optimization in Dennis Horber's presentation. That was the one with the automated derivation of evaluation criteria. But if you look in the chat, that was already answered. Maybe you would like to comment on it, Mr. Horber?
Mm-hmm. I assume there's a wording problem over here because the optimization criteria is only used in multi-criteria decision making. So this type of criteria has to be optimized. So the degree of fulfillment is of interest in decision making. So if a requirement or criteria is fulfilled better, then the alternative gets a higher rank. And apart from that, the selection criteria is the opposite one. There is no interest in the degree of fulfillment. So it only has to be better, but the degree is not of interest. I hope that answers the question.
Yeah. Thank you. I mean, in all presentations, I read all the papers, and there's much more in the paper, so I advise maybe that you also have a look. But in this presentation to derive evaluation criteria, I think this is a very important issue because there's not much on this topic at all. I mean, we all know requirements play a role, but how to translate them is usually experience. maybe I can pose a question to the mouthpiece presentation. I think Mr. Öztürk is not present, but I see Gaetano, Cascini. I was, when reading it, I was wondering, could we generalize this method, which you have shown in the example?
So thank you, Christian, and of course, good afternoon, everyone. Well, actually, this is just one of the case studies in Mehmet PhD work. So he's developing several case studies. The one that he's finalizing now concerns shoes to be customized both in terms of model, decoration, so the aesthetics, and also some aspects of the ergonomics. But the logic is exactly the same as you mentioned, Christian. So the point is to enable mass personalization, giving to the user the possibility to choose some values of the requirements they want to give a personal flavor. The essence is that by making some choices of some value of the requirements, not necessarily the other requirements keep the full spectrum of variability, because based on the analysis of the design, what happens is that it could be that if you choose, as in this case, the mouthpiece, if you choose a certain I don't know, shape or size of one of the, for instance, of the chambers dimensions, then other parameters have a smaller variability, because it wouldn't make sense to leave the entire interval available. So it is somehow embedded in the intelligence of the system, and then using rapid prototyping or manufacturing technologies, it can be produced exactly what the users wanted or requested. So in general, the logic could be repeated. He has developed also a third case study in the field of dental lamps, so lamps for dentists. So just to say that it has a certain applicability in many different contexts. Clearly, and to be honest, it requires a certain amount of work to produce the seat design and to allow the users to make their choices according to their preferences. But the overall approach, I would say, it's quite general. I mean, this is at least our ambition. I see that for some reason, the chair of our session has some connection problems.
Yeah, we will wait for him to come back.
Okay, may I, since I'm talking, may I use the possibility to make a question?
Of course.
Thank you. And sorry, it's again to Dennis, and then I hope that everyone will have the chance to make questions and answers. But I was wondering when attending the video, but I'm honest, I didn't read the paper still. Well, that part of the motivation is to be able to validate the requirements, especially when you are dealing with complex systems. So with requirements that cover different domains. So it is something that is across many domains, which is, of course, really sensible. I fully agree. Then you present the possibility of use natural language processing to, of course, to automate or to make this process as efficient as possible. And I was wondering, I mean, one of the difficult things in natural language processing is the multiple meaning of some words, of some nouns, that normally it is addressed by knowing what is the domain in which that text applies. And so I was wondering, here you have a kind of contradiction, because you might want to use the reference to a specific domain in order to interpret the meaning of some nouns that would have different meanings, and on the other hand, you are working in a complex field where you have multiple domains. So maybe, I don't know if you face this kind of problem and if you have any suggestion on this regard.
Thank you for that question. I already read in the chat that Laura Augustin also had a similar question where she asked about greatest challenges I see in the topic. And that is indeed a big challenge because the language model is the basis for the whole language classification. And our approach is not to always classify it in every topic the same. So we want to show the information to the user when he types in the requirement, how this requirement is understood in the language model that's programmed or trained in the background. So if this contradicts to the user's intention that he wants to have, that the requirement has to be understood, then he has to think or to rethink the requirement statement. So our goal is that the user sees the requirement and the understanding of it. And if this is not or doesn't match his intention, then there is some sort of problem. And this could, come to problems in other other departments or when other persons, involved persons in the development have to understand the requirement. And this is the main problem we want to address. And yes, the development of the language model is a huge challenge in this front.
Okay.
And you also asked for the solution approach that I see right now. It's we want to train the model based on old requirements. So they have to be classified manually and then train the model. But this has to be implemented further. So this is not implemented right now.
Daniel was about to say something.
Yes. I also had a question, at least about if you are thinking about matching different requirements from different fields, because in the research project, it's a pain talking with IT system guys and service developing guys, and the product developing guys, we all use the somehow same words for different things. So I think it's a really interesting idea finding a possibility to translate them and maybe also match same requirements which are formulated differently. So yeah, I'm really looking forward about what you're doing next in your work.
Yes, like I said, it's our idea not to match the requirements so it fits in every department and everybody understands it in the right way. So we add the meaning to the requirement. You have to, I think that's easier to understand if I say it's like this. But thank you very much. Okay.
I'm afraid that, Christian, you are still muted, sorry.
Microphone is not working properly, I think.
I do have another question about the mass personalization approach. Do you thinking about a parametric or an underlying model which you can use directly with your constraints or your parameter which you are varying with your requirements?
Yeah, so to clarify a bit better, I mean, given a certain product we would like to personalize, what we suggest is to recognize what are the possible design variables, the design parameters that one might control, and what are the requirements that the design parameters affect. Of course, the design parameters could be quantitative variables or even just options, squared or rounded, just to say. So with a kind of design structure metrics approach, it is checked what parameters affect what requirements. Then with the logic kind of triangularization, it is try to understand from where it is better to map the relationship either by simulations or with experimental with experiments. As in the case of the mouthpiece, there is no literature and it was too complicated to run simulations to predict the brightness or the kind of sound of the mouthpiece based on simulation. So it was purely experimental. And then with an inverse process, we define a map of relationships between requirements you would like to get and specific values of those requirements and the configuration of the design variables. And then this is used to automatically control the manufacturing of the specific product. In this case, I mean, the lucky thing is that a mouthpiece is a tiny thing that can be quite costly. So the manufacturing is, I mean, something, let me say, negligible with respect to the real value of the thing. So if you do something that really makes sense, the user is happy to pay a bit more than what they would pay a normal product, as far as it really fits their expectation, which is the concept of personalization in the end.
Can you hear me again?
Now we can hear you, Christian.
Yeah. I just placed a question on the chat, which kept working, even though I lost all of you in the meantime. That is for Daniel.
Yes. Yeah, in this approach, we just had our focus on the requirements for the product in the product service system. Professor Weber just left again, but I can answer the question anyway. So we focus on the effects we have on our product in the product service system, because the requirements for the system itself is, again, completely different. And at least what we wanted to show in our paper, or what the main goal was, is the realization that not the product which seems the best product, either in the way of costs or in the way of capacity or something like this, is the best one. So this paper is just like an experiment about if we look at the whole system, not always our typically best product is our best product. So it was more just like a experiment we've done with our service system. And yeah.
It seems we have again a problem with our chairman. So, well, I was typing, but maybe I can phrase my question. This one was for Robert, if you allow me. I like the project, very nice. I just think that, well, as many of these kind of activities, requires a lot of time to develop a case study, for instance. So I was wondering, what is your plan for validating the model you are proposing? Because I mean, of course, one case study is an example, but how to generalize, of course, it is a bit more complicated. So I was curious to know what is your strategy in this sense, if you have already some plans, because I think it's interesting for all of us in a sense.
Yeah. So can you hear me well?
Yeah, very well.
Yeah, thank you for your question, Gaetano. I like the question because, in fact, it allows me to also say that when we gathered these requirements and also wrote the paper, it's been some time ago. And by now it feels like quite a long time ago because we've made some progress on this. In our research project OpenNext, which we initiated at the beginning of the year, we started some research where we did interviews with different users for a platform that we want to develop further. An existing platform and to understand what are the needs from different perspectives, and also we then let's say started all over again, I wouldn't say dismiss this research, but let's say we took another path, which was to look at use cases and derive from there critical functions. And yeah, I think it was for us, this research was more important for us to first of all get an idea in which direction we should be going, and it allowed us.
In a sense.
Yeah. Sorry?
I said it was more exploratory. So you
yes, it was very
yeah. Makes sense. Yes, because you need to understand what are all the relevant issues in order to focus better for the next direction. Yes, because again, I think it's very interesting, but it is also let me say very, very complex to recognize something that has a general validity and it is also validated properly.
Yeah, it did allow us one thing which it doesn't say in the paper, but now come to think of it, we did actually start working with this company called Wikifactory because of their website and platform, which we analyzed in the paper, and it was this research which led us also to start working with them, and they became part of our project actually.
Christian,
I think I'm back now, maybe a little more stable than before. I see a question of Alaa Hassan about the simulation software used in Daniel's presentation. Hello?
Sorry, I hit my microphone. So in this case, we used YAMSIM for the simulation. My colleague, Mr. Siqueira, did the most of the simulation building. So I'm sorry that there I'm not the expert. So I hope this helps.
Okay, no problem. I will read the paper anyway. Thank you very much. Because just my question was, as I can see at the title, it's a discrete event simulation. So when you presented the project, I could see that it was also a simulation of different scenarios. So maybe we don't need a discrete event simulation. It's just to which we call the dynamic system simulation, which is offered by many packages like even Excel, for example, MS Excel. You can compare different scenarios by simulation of different scenarios, and then to decide which scenario is the best. Maybe discrete event simulation, as I know, it will be a very big tool for just a simple comparison, for example.
Yeah, if you're talking about dynamic system simulation, it's the one, the system dynamics, which is based on Forrester, or is it different?
Yeah, as a simple tool for it, as which we can use in Excel or Python or just software like this.
In my main work, I'm working with system dynamics. This discrete event simulation was just a side part. We were just at least looking and trying out a little bit.
Yeah. Okay. Thank you.
Okay, so we're going to continue with this chairless session. Well, I'm very sorry for Christian Weber. Of course, he is absolutely not responsible for what is happening. I don't know whether any of the speakers, of the panelists, has more questions, or even if someone from the audience. I see that there are still 19 people connected, so maybe more questions from their side. We still have a few minutes for this session on requirements engineering. Yeah, please, Daniel.
Otherwise, I do have a question about the V-cycle presentation. At least you implemented everything on the left part of the V-cycle, right?
Yeah. Yeah.
Do you think there is a possibility also the integrating and testing on the right part of the V-cycle?
Yeah. Yeah. Thank you.
Integrating in your approach?
Yeah. You know, V-cycle is for the two models, for system engineering model and design thinking model. For the two models, we have all the development, product development cycle, requirements to test phase. So I think in principle we can study this possibility to integrate the two models in all the phases, the development phases. But as a first step, we decided to start by the requirement analysis, because the design thinking deals with an aspect like disability, and in design thinking we have another approach which can help us to identify some requirements which are not identified in system engineering model or approach. So starting with this phase to enhance the requirement analysis phase is just the first step, because we think that for the other phases there is not a big difference between the two approaches. Even the system engineering approach is very developed in the manufacturing and testing and validation step. It's okay for you, or is it clear? Is it clear?
Yeah.
Well, I would like to attract the attention of what Georges Fadel just posted in the chat. I think it is mostly relevant for Dennis, but well, more in general, being related to requirements. And well, I don't know whether George, you want to mention. I mean, you want to speak directly, or I can read it. He says that at Clemson they have a big group working on requirements, and he mentions that Greg Moko is also working on natural language processing and simulation models. So somehow highly relevant for what Dennis was presenting. And also on Joshua Summer is working on requirements validation, and Cameron Turner on surrogate models to support decision making. So in this perspective, and well, of course, himself working on trade-off tools to help decision makers. So it seems a good combination of several points that were raised not just by Dennis, I would say, if I read the entire message, but also by others in this room. So of course it would be nice to establish a link, maybe in the break session, also using the facilities of this virtual conference. It was way better to have a physical location where to meet, maybe have a drink together, but we will somehow face the situation. And so I'm sure that George and colleagues from Clemson will welcome any contact and any direct interaction on these points. I didn't know the mouthpiece, George. That's interesting. I'm sure that I'm curious to know what you did with mouthpiece. Definitely. More message from Christian. It's. I mean, I'm very sorry that you cannot make it. I'm sure you would have done a great job. What I cannot do, even because I was not even supposed to attend this side of the meeting, but a number of combinations made me play this role today. I don't know whether there are more questions or comments from the audience, even just reflections that emerged along the discussion today. Not really. Daniel, I see that you are almost about to say something. I'm not sure about it.
No, not really.
Okay. In any case, I would say that it was definitely an interesting one, despite the problems that, of course, are not intentional. It is good that the organizers prepared the conference in this manner with video recorded presentations so as to avoid troubles and having at least a starting base for discussion. And somehow I think that we had the chance to clarify some points with question and answers and some comments. I wish to all of us that was the chance to go even more in deep. Definitely reading the paper is part of the game, but having direct interaction is something else. Thanks also from my side. Christian is greeting us as, of course, chair of the session. Hope to see somewhere in the sessions later today or in the tomorrow. Enjoy the rest of the conference.
Thank you very much. Thank you, everybody.
Bye-bye.
Yeah, thank you.
Bye-bye.
Take care.